All right, in this video, we're going to take a look at some more examples of using trig identities and algebraic techniques to solve trig equations. So example 2c, we have cosine of 2x equals 3 cosine x minus 2. And here we have cosine of 2x, so we're going to have to use the double angle cosine identity. Now, we did have three different forms of it, and in order to know which one to use, let's look at the right-hand side where we have a cosine of x. So because we have a cosine of x on the right-hand side, we want to use the 2 cosine squared x minus 1 form of cosine of 2x. If there was a sine x over here, if it was 3 sine x minus 2, we would want to use 1 minus 2 sine squared. But because we only want to have one trig function in an equation to deal with, if we can, we're going to use 2 cosine squared x minus 1 as an identity for this double angle cosine. So using that, we get 2 cosine squared x minus 1 equals 3 cosine of x minus 2. So it is a quadratic equation. We want to get it equal to 0. Let's subtract 3 cosine x from both sides and add 2 to both sides. We get 2 cosine squared x minus 3 cosine of x plus 1 equals 0. And believe it or not, the left-hand side is factorable. So when we do that, we get 2 cosine x minus 1 times cosine of x minus 1 equals 0. If it's not factorable, you'd have to use the quadratic formula, which would give you cosine of x or sine of x or whatever equals some crazy expression that would get pretty ugly, but it is possible. But this one's factorable. We can set each of the factors equal to 0 and solve. So setting 2 cosine x minus 1 equal to 0 and setting cosine of x minus 1 equal to 0. For our first one, we get cosine of x is a half. For our second one, we get cosine of x is 1. The good news is the half and the 1 are all both located in our cosine column. So the values of x that where cosine is a half are 60 and 300 degrees. For cosine of x is 1, we have 0. Remember, we're not including 360 degrees. So 0, 60, and 300, we can write those in their radian form as 0, pi over 3, and 5 pi over 3, respectively. All right, part D, sine of 2x equals the square root of 3 times the cosine of x. So the good news is with sine of 2x, we don't have 2 or 3 different forms to choose from. We only have one. So we don't, as far as how to get started, let's rewrite sine of 2x as 2 times the sine of x times the cosine of x equals square root of 3 times the cosine of x. Now again, we don't want to divide both sides by any functions here because we could be risking them equaling 0. We don't want to divide by 0. So rather than do any division, let's subtract square root of 3 cosine x from both sides and get this thing equal to 0. So we have 2 sine x cosine x minus square root of 3 cosine x equals 0. Notice both of these expressions have a cosine of x in them, which means we can factor out a cosine of x from both of them. So if we factor out a cosine of x, our first expression will give us 2 sine x. Our second expression will just give us square root of 3. So we have cosine of x times 2 sine x minus the square root of 3 is going to equal 0. So now we can set each one of these factors equal to 0 and solve. So set cosine of x equal to 0 and set 2 sine x minus the square root of 3 equal to 0. Cosine column, we got 90 and 270, where cosine is equal to 0. And if we add square root of 3 and then to both sides and then divide by 2, we get sine of x is the square root of 3 over 2. That happens at 60 degrees and 120 degrees. So we have 4 angles between 0 and 360 that make this original equation true. And converting them to their radian form, we get pi over 3, pi over 2, 2 pi over 3, and 3 pi over 2 for our answers in radians between 0 and 2 pi. All right, that about does it for this video. Thanks for watching. I'll see you next time.